So to illustrate the strong range rule of thumb, we will talk about an example. Specifically, when we're working with data that we suppose is normally distributed, in other words, has a bell curve shape, is approximately symmetric, then we're free to use the strong range rule of thumb. And just to refresh your memory, we mean any data values in our data set that are less than 2 standard deviations below the mean or greater than 2 standard deviations above the mean. So let's suppose that we have a machine that cuts keys with a precision rate with mean 97% and standard deviation 0.4%. We can reasonably assume, by the way, that this is going to be normally distributed data just because when we talk about precision and machine accuracy, these are frequently modeled using what we would call normal distributions. So that bell curve shape is definitely present here. Another place where it's typically present is when we're talking about complicated variables or measurements that we take about people, because those tend to feature a lot of different variables that are acting at once. We'll get more into that later. On one test, though, the machine's precision rate is 94.3%. So you've obtained a data value, and we want to ask, is this significantly low? So the way we should check is we should evaluate whether, so what we're really asking here is, and I'm going to convert to decimals because it's just going to be standard for us to work with decimals rather than with percents. Is this data value less than the mean, so the 97%, minus 2 times 0.004? Because that's what 0.4% means. So just to remind you, so this is our data value. This is our mean, sample mean, but it also works with population mean. So it could also be like that, where instead of the sample mean, we're working with the population mean, and instead of the sample standard deviation, working with the population standard deviation. So this rule works for both cases. And then we would have to calculate that. And so if we do this calculation, we'll find, and excuse me, I'm calculating right now. You get 0.962. Okay, so roughly 96.2%. And since it is less than, so this statement is true, our 94.3% is lower than this threshold, then we would say, so yes, this is significantly low. Significance plays a large role when we talk about probability and inferential statistics later on. So keep this in mind. The strong range rule of thumb and the empirical rule really is telling us a lot about what our usual range of data values is, especially when we can model things using these bell curve or the normal distributions.